Good morning, good afternoon, and good evening, everyone. And thank you for attending Xylem's Spotlight webinar on sump pumping in mineral processing plants using Flygt 5000 series pump. This webinar is brought to you by Mining Center of Excellence. So a little bit for introduction for today. A little bit about myself. My name is Liran Hillel, and I'm an application engineer in Mining Center of Excellence. And I will be your host today and also the co-presenter. On the agenda today, we'll have an application overview on Slurry in mineral processing. This will be followed by a product presentation and the case stories delivered by our speaker, Ryan Macdonald, who is the dewatering product manager for Australia and New Zealand. And to wrap up, we should have about 10 minutes available for us to answer your questions. Also on the call today, assisting Ryan and myself to answer your questions during the Q&A session, our Mining Center of Excellence team members, Paul Gaby, Michael Skovaga, and Shane Matthews. So slurry pumps in mineral processing. So to start with, we need to understand a little bit what is mineral processing and what is slurry. So mineral processing is basically the art of treating ores from a mine site in order to separate the valuable minerals from the waste rock. The wet stream in the process usually contains wet slurry, processed water, reagent, and potable water. Typical slurry process will include slurry transport pumps and also slurry collection sump pumps. In this slide, you can see a few pictures from a typical mineral processing plant. If you look at picture 1, 3, 5, and 6, you can actually see a typical slurry collection sumps, or as we call them, a washdown sumps. These sumps are located at the ground level of the processing plant. The pumps are actually installed inside these sumps and installed for the purpose of collecting the valuable runoff slurry from belt filter and conveyors and other equipment, and basically recycling back to the process. We will be focusing on this type of pumps in today's session. So we'll start with understanding what is slurry. So when we are talking about slurry, we need to understand basically that slurry is a mixture of solids suspended in the liquid. The liquid role is solely to be a carrier for the solids, and in most applications, that liquid is actually water. The water source on site can be anything from potable water, recycled water, processed water. It's all depending on the availability of the source on site. The solids also can vary in their size, weight, and texture. It can be anything from hard solids, coarse solids, heavy, abrasive. So to transfer the solids into a pumpable solution, as we call it, that can be then transported using pumps, we need to add liquid, as mentioned. Slurry can be described as a two-phase medium, liquid and solid. Typical slurry characteristics are basically split into three main categories: light, medium, and heavy. And it can range between 10% to 60% concentration by weight, and it depending, of course, on the application. The slurry concentrations higher than 40% by volume might require the use of progressive cavity pump or PC pump due to basically its high density of the slurry. Here you can see a picture. You can see a submersible slurry pump inside the collection sump. So slurry analysis, we'll talk about slurry analysis and why it's so important to understand and to analyze the slurry. So pumping slurry raises a different requirement for a pump compared to a pumping just water. Here in the left, you can see three curves. You have the power curve, the head curve, or the flow and head curve, and the efficiency curve. You can see the brown curve represent the slurry curve versus the blue curve, which represent clean water curve. You can clearly see that when pumping slurry, the power consumption is actually higher. The Q and H curve, the head is lower, and obviously the efficiency also lower. So in order to select the right pump for the job, we need to collect information on the slurry type and the application. And for this purpose, we have developed our slurry questionnaire. In this questionnaire, you'll see key questions. Answering key questions regarding the slurry properties and the application. Questions such as concentration, particle size, specific gravity, required flow rate, and also piping system will allow us basically to estimate and calculate the head losses in the system and select the right type of pump for the job. The critical velocity, as illustrated in this diagram here, indicates the optimum velocity where the head losses are kept at minimum. So as you can see here, velocity that is too low will cause to increase in friction losses, and velocity that is too high will also cause to increases in friction losses. So we really want to keep a velocity on the sweet point to maintain the slurry in suspension. In general, the pump should be able to push the slurry through the piping system and maintain the minimum required velocity in order to prevent slurry from settling inside the pipe. Therefore, the key slurry parameters such as solid size, concentrations, and piping are really essential for identifying the slurry type and its behavior, and also for selecting the right size pump. Here you can see a cross-section of a pipe with three different types of slurries. You can see the first pipe, a slurry that is fully homogeneous, fully suspended. And the middle one, you can see that the slurry is partially suspended, but also partially settled at the bottom. And then the third pipe, you see a settled slurry. That's exactly what we want to prevent, and hence we need to keep the velocity sufficient enough. And it's also depend on the size of the particles and the concentration of the particles. I will now hand it over to Ryan Macdonald for the product presentation. Over to you, Ryan.
Hi everyone, thanks Liran, and thanks to the mining COE team for asking me to help with this webinar. A little bit about myself. I'm Ryan Macdonald. I'm based in Perth, Western Australia, and I've been with Xylem now for 8 years and working with the product marketing team for Flygt submersible pumps for the past 4. Today we're going to be focusing on slurry and mining, but with a particular focus on washdown sumps. And for anyone that's not familiar with washdown sumps, what a washdown sump is anywhere where there's material handling or ore handling on site, and generally when we're moving from one transportation method to another, i.e. with trucks to belts, or belts to loaders, or trains to conveyors, there's generally a lot of ore runoff. And when there's ore runoff in site, we need to recover that ore to get it back into the primary process. Washdown sumps generally collect the ore and use liquid as a medium to pump it back into the main process. And you can see an example of that in the first slide. That's a washdown sump there. So for anyone that's not familiar with this application, that's a pretty good example there. With my part of the presentation, what we're going to go over is a little bit about the Flygt product and where that fits with washdown sumps, in particular in processing plants within the mill, our processing facilities and mining. Then we're going to move on to a couple of case stories, which hopefully will showcase some examples of applications in general. To get started, there are lots of different slurry pump types out in the market, but when we're talking about slurry pumping on the surface, and generally floor sump pumping and slurry process, we're generally talking about centrifugal pumps. And for anyone that's not familiar with what a centrifugal pump is, a centrifugal pump uses an impeller and a rotor and spins to create energy, to turn the liquid into flowing head and create a bit of a movement within the liquid. When we're diving in a little bit further into slurry pumps on a mine site, and centrifugal pumps in general, the pump on the left-hand side of this slide you can see is an end suction pump, which you'll generally find to be a process pump in the main operation part of the mill. These are generally referred to as the beating heart of any ore processing facility. And like any heart, when they fail, the site will generally go into cardiac arrest and fail. And that's the kind of main component of the mill. Without the main slurry pump, the site will stop and won't be able to produce any ore or separate any ore from the main mineral. Now, the interesting thing about process slurry is they try and keep the solid content as high as they can and minimize the liquid content. And the reason for that is they're trying to maximize the amount of ore they can push and move around site. Some of the benefits of this is you can generally predict when some of the components are going to fail, but it also means the pumps need to work really hard. And if you can imagine when you're on a beach, maybe an analogy to understand the abrasive nature of it is if you dig your hand into the sand and start to turn it, you can feel that it's coarse and rough. But when you move it closer to the ocean and put your hand in the liquid and still have some solids in suspension, you don't get that same abrasiveness. So basically, the higher the solids density ratio to liquid is, the more abrasive it will be. Now, that's not what we're going to focus on and talk about today, but I just wanted to clarify that because a lot of people, when thinking about slurry pumping and mining, are thinking about moving the product about site. But what we're going to talk about today is sump pumps. And what sump pumps are trying to do is recover the runoff, as I discussed in the intro, recover the runoff back into the primary process. If you can imagine, if we didn't have these sumps, what would happen is the ore would come off of the process and we'd generally have to get it back in by either hand or a front end loader, which is a very inefficient process. One of the main benefits of sump pumping though is instead of trying to get the solids to liquid ratio up, we try and reduce that. The more liquid we've got, the pumps don't need to work as hard, and also we don't get as much abrasion, which means the pumps will generally last a little bit longer. So diving into the washdown sumps, as we mentioned, and going on a bit more of a deep dive about the two different options you've got. Firstly, we'll look at semi-submersible pumps, which are often referred to as cantilever pumps. And what you'll find with cantilever pumps is a long 2-meter structure that sits like a motor that sits proud above the surface, and the volute and impeller that sit about 1.5 meters below the floor of the mill. Some of the limitations for this product is each sump will need a different depth, and what we're trying to do with slurry is obviously pump the solids back into the process. If the volute isn't close enough to the ground, then we won't get the settling solids from the bottom of the sump. So we need to end up having a variety of different models around the plant, because one size doesn't fit all. So depending on the depth, we'll need a different pump. Some of the other limitations are the motor sits proud in events where in processing facilities where you have large volume dumps, you can get flooding. And although the motors have high IP ratings, they're not submersible, and it can sometimes cause issues. But one of the main problems we have with cantilever pumps is, if you can imagine a processing facility, there's a lot of pipework, conveyors, tanks. We don't have a lot of space to work in, especially at ground level. And when you're trying to install and remove these pumps, the lack of overhead crane height can become an issue. So some of the benefits of using submersible slurry pumps are really the small, compact nature. They're less space and really easy to handle. Because they sit at the bottom of sumps, we're able to use the same model across all sumps and standardise across the site. And then because they're submersible, they're flood-proof and really easy to install. But one of the main benefits I like with the Flygt 5000 submersible pumps is, if you rationalise in one pump model, the customer can generally settle on one model across the full site, which minimises the amount of stock they need to hold on site. And then when you sometimes get kind of ad hoc jobs that you need to do around the mine throughout the year, for instance, process dam recovery, these pumps are so versatile that they can be used for that as well. So you can hold one pump in your stock holdings for your kind of submersible or float washdown sumps that can also be used in other applications throughout the year, which is a massive benefit. Just going on the product range, this is quite a busy slide, but I'll do my best to try and keep it interesting. You can see we've got 9 variations of model, starting out with the 5520 and 5530. These are the smaller models, 3 kilowatts and 6 kilowatts respectively. These really come into their own when we've got really tight areas around the plant and you only require small flow rates. Moving up, we've got the 5100 series, which the 100 in the 5100 series signifies the discharge size. It's 100 mil or 4 inch. It starts at 7.5 kilowatt and goes all the way up to 45 kilowatt. And then we move on to the 5150, which is a 150 mil discharge pump, which ranges from 30 kilowatts all the way through to 70. And then we've got the granddaddy of them all, the 5570, which goes all the way up to 215 kilowatts and can produce flow rates of up to 325 litres a second. So just kind of anyone that's playing along at home with the poll question, we've got 40% of the audience are utilising semi-submersible cantilever pumps in the process plant. So that's an interesting stat for you, and also just shows we've got 135 people online at the moment. So that's quite a high percentage. We've with just a little bit more of the product, we've got internal cooling on the 5100 range, which is a standard range. This is glycol, which is pumped in between the stator and the outer jacket. This allows us to pump the liquid all the way down to the volute without overheating the motor, which is a great feature. The larger pumps have got an external cooling option so that we can also pump down to the volute and let the pump snore a little bit. And all the pumps come with, apart from the smallest 3 kilowatt pump, come with an agitator option, which with slurry pumping and washdown sump pumping is one of the most important features, because we need to keep the solids in suspension to enable us to move the solids around and get them out of the area. We also have warm liquid versions at 70 degrees, and each model comes as an EX version, which is compliant around the world for IEC EX, which is explosion proof for anyone that's never heard of that terminology. So just before I move on from this slide, you can see that we can cover from 10 litres a second all the way up to 325 litres a second. And with our standard range, we can go up to 50 metres. And with the Grandaddy 5570, we can get all the way up to 90 metres. So there's no real washdown sump that range can't cover. In my experience, I've not came across any that are higher depth than that. Unless the pipework's too small. Some features and benefits, just staying on the product. We've got high chrome wear materials. Obviously, when we're pumping abrasive material, we want to have the hardest material possible, which we have. We've got impeller design with a 40mm throughlet. It's a closed impeller to maximise the efficiency. A large volute for reduced wall velocity. So if you look at the edge of the impeller to the edge of the volute wall, you can see the gap's quite large, and that's on purpose, because what we're trying to do is slow the liquid down to a speed where it becomes slow enough not to wear the material down, but keeps it travelling fast enough to keep the turbulence high enough to keep the solids in suspension. Spin out groove, this uses the centrifugal force of the shaft, and also there's a groove that goes in the reverse direction in the seal housing, which removes any debris from getting stuck in the seal chamber. Low pressure zone for reduced seal wear. If you can notice behind the impeller, you can see between the hub and the seal housing. Don't know if you can see on the pointer here, but that small gap creates that pressure drop, which means we have a lower pressure area in this area, which means we can add flushing water while the pumps are running, which is a massive benefit if you have slurry that tends to stick and coat the seal when the pumps are off. Plug-in seal, when we do remove the agitator and impeller, when the parts eventually do wear out, the plug-in seal can be changed in a matter of minutes and is really dummy-proof when in installation. It's really straightforward and it's really difficult to break on installation. High efficiency motors with built-in sensors. The built-in sensors part is pretty important with slurry pumping, as we know if we don't introduce enough water into the sumps, then we're likely going to bog the pumps. And this is a great feature that indicates if the motor's overheating due to being overloaded. Leakage detection, which sits in the stator housing. If we do get any leakage from the seal, this will send a signal to the controller, which indicates that the seal's been compromised. And for our customers, that means that they can pull the pump out before we get a catastrophic, expensive failure. And optional internal cooling, we offer this as standard in Australia in the 5100 series and 5150s. This gives us the ability to run the liquid all the way down to the inlet of the pump without overheating the motor. If we didn't have the cooling jacket, we would usually what happens is it's the fluid that's getting pumped that helps cool the motor. And this is a great addition, which means we don't have to have the fluid sitting above the top of the handle. And the agitator option, which, as I mentioned before, is vitally important for keeping the solids in suspension to keep the sump clean and the surrounding area clean. One feature about the impeller is anyone familiar with our end pump range in wastewater will know that we use a semi-open impeller. In slurry pumping, it's important to use a closed impeller because of the abrasive nature of the fluid we're pumping. As soon as the veins, a gap appears between the veins and the wear plate, any water that passes over the veins will wear the open impeller down really quickly. The difference with the closed impeller is we still get the large throughlet through the impeller for the solids, but when we go to repair the pump or take it out for maintenance, we can just retrim it back to its original flow and performance. And it usually almost gets back to full performance every time. Whereas with an open impeller, each service you're generally changing the impeller out. Agitation, which I mentioned, is pretty important with keeping your sumps clean and keeping the surrounding areas. Keep in mind everyone's washing down all the solids into the sump and we're trying to recover it back into the process. And I'd use the analogy here that if anyone's ever been on holiday and they've went on a glass bottom boat, when you look and it's a still day, you can see the bottom of the sea floor and all the sand sitting on the seabed. And you can use that in an analogy for the top right hand photo. You can see all the solids are sitting on the sump floor. If you can imagine the agitator's a bit like a storm, if you've ever been unfortunate when you're abroad or on holiday to go out the day after a storm and you can't see any of the fish or you can't see the seabed, that's exactly what the agitator's doing. It's putting energy into the fluid, creating a thrust down onto the floor of the sump, which is creating turbulence, suspending the solids and letting them transport around the fluid and letting us pump them back into the process. And that's pretty much what's the same thing as it happens during a storm in the ocean. The only thing is the solids all get transported onto the beach. But it's exactly the same thing that's happening there. For any sumps that haven't been designed to suit 5000 series pumps, you can see the top two images have been designed for a submersible pump. You can see the edges are all funneling down into the agitator. A lot of the times we are replacing cantilever pumps and they're going into large sumps that haven't really been designed well, and they've got a lot of spots that have settled solids and dead spots. At that point, we'll generally use a mixer to help resuspend the solids. So we've got two options there, but generally we'll try and keep it to the agitator, but for larger sumps, we'll use the mixer just to help boost the solids and get them back into suspension. One thing to remember is with slurry pumps, we're trying to pump solids, whereas the majority of other pumps were trying not to pump solids. So we're really trying to move the solids. And if you want to pump solids, they need to be in suspension. So just a bit of a product summary before we move on to some case stories. Some of the highlights are the agitator, the reliability due to the high chrome parts. But really the big call out is the smaller footprint and it's less bulky. It's really easy to transport around site once it's removed for maintenance. Also the standardization. This is where I find that these pumps really come into their own. We can choose one pump for the full floor sumps, all the floor sumps around site. There's no real infrastructure required and they can be used in multiple locations. And as I mentioned before, for the ad hoc jobs that you need to do throughout the year, process dam recovery or tank transfer, these pumps can also be used for that. So it means that you only need to hold one pump in your stock holding. It makes it a lot easier. And we generally have these pumps repaired off-site, although they can be repaired on-site. But that means that the stock that needs to be held by the customer is only one pump, and that's it. They send the pumps off-site to be repaired at service centres and generally have one or two pumps in rotation. They're ideal choice for washdown sumps. So now we're just going to move on to some case stories and some partnerships that we've had with customers over the years that showcase the success of these pumps. And this is really what I love about working with Xylem. It's partnering with customers to help solve their issues by using our products and also to maintain a common goal. So they come with a problem and then we implement a solution that helps get them where they need to be, and we also get to use our solutions. This case story is based out of North Queensland at a zinc concentrator, and they were struggling with the mean time between failures of some of their washdown sumps that were only lasting between 4 to 6 weeks. Some of the customer pain points they were seeing was the wear components weren't lasting. When they were starting to wear, the efficiency was dropping right off, and they weren't producing enough head to meet the pump boxes, and we weren't able to pump the fluid back into the process. Because there's no agitation, the solids were building up around the volute and impeller, which meant that there was a build-up of solids around the sumps, which then led to the areas flooding, creating OH&S issues. Because there was actually no control philosophy on the pumps, so they were constantly running, which meant that they were noisy and snoring. And if you've ever got a noisy, snoring pump, the energy that should be going into pumping fluid is going into creating noise. It generally means the pump won't last very long, and it's not very good for the pump life. This customer was trying to maintain all the pumps on site, and because all the sumps were different depths and different sizes, they had a variety of models. This meant they had to have loads of different parts on site, which meant when they ran out, they ended up with long lead time for repairs. When the sumps did bog, they had to use sucker trucks to get the sumps back online when they were bringing the pumps back in. And they were finding they're having constant flooding, which was leading to costly repairs and downtime. And it was taking up a lot of the on-site maintenance staff's time when they really wanted them working on the preventative maintenance schedules that they had scheduled for, rather than breakdowns. So it's creating a lot of inefficiencies out with the floor sumps as well. So, task at hand, we had to select the correct pump for the duty. In this case, we were only going to trial it in one sump, but what we thought is important to do was trial a pump that we could use in all 13 of the sumps around the floor the circuit. And the reason for this was we wanted to solve the other problem the customer had, was that they didn't want to hold all that much stock, and they wanted to reduce the stock they had on site. So it was important for us to standardise on one pump. And in this case, we chose the 5100 30 kilowatt. We implemented mixers as well as the standard agitators, because the sumps had initially been designed and they were having some dead spots. So we wanted to make sure that the solids remained in suspension as much as possible. We implemented some E&M 10s and some pumping controls to make sure the pumps only ran when there was water, which is important. And we utilised the high chrome wearing parts, which we were hoping would last longer than the previous supply. And as a result of the pumps being submersible, they're generally flood-proof and quiet. So with any trial, it's important to have some KPIs in play, and we really wanted to make sure we were measuring the spare parts and reducing the amount of parts that they were holding on site, because that was one of the major pain points. And then we wanted to reduce the breakdowns and implement preventive maintenance. That was easy because we had a datum point that the current supply was only lasting 4 to 6 weeks. So we knew anything better than that was going to be a success. So just a bit on the slurry pump poll question too. The most common pain point we've seen was significant pump component wear, which is was interesting. That was closely followed. In fact, sorry, I've got that wrong there. The highest pain point is solids build-up, which really doesn't surprise me. That's kind of goes in theme with what I tend to see when I travel to site. So thanks very much for participating with that. So as I mentioned, we had some key metrics to follow and make sure that we are going to achieve. And the first part of it was we strategically chose 8 weeks to pull the pumps up and the pump up and check how it was doing. And the reason we chose 8 weeks was because the pump previously had only been lasting 4 to 6 weeks. So I thought it was important to pull it up after 8 weeks and see how it was going. And the interesting thing was the performance had been maintained and there was absolutely no drop in flow. The seal leakage inspection chamber was clear, which meant the seal hadn't been compromised. And after the agitator demonstrated very little wear, which was an encouraging sign. After 8 weeks, the customer was so impressed and the expectations were exceeded, they started placing orders for the other 13 sumps that they had on site. Now, when we pulled the pump after 12 weeks for a full evaluation and actually took the pump apart to inspect the wear, the glycol in the cooling jacket was still clean. The volute had minimal signs of wear. You can see it's slightly worn, but not worn anywhere near enough to change it out. The agitator had worn slightly, which is a good thing. It shows it's working and doing some work without turning into a grinder. And the impeller wore out slightly, but again could be reused. So this to me shows that the Flygt pump was going to last longer than 12 weeks. But for the sake of seeing what this means to the customer and our OPEX costs, the cantilever in a 12-week interval required 2 maintenance intervals, whereas the Flygt submersible pump was still going strong after 12 weeks. When you compare the costs, I kind of hate this part because we've got it there, it's got 2 service intervals and it costs it was costing the customer roughly $30,000 each in each 12-week period. Now, we've got it costing roughly the same for a service there, but as you've seen from the photos before, we didn't actually have to replace the parts. So you could argue that this is actually much less, but for the sake of, we says at the start of the trial that it was going to be a 12-week trial. So this is the way we've analysed it. We've put the replacement parts as if all them parts were actually replaced, even though they weren't. And since then, we've found the pumps get pulled in regular intervals around every 6 months. And generally, the majority of the parts don't need changed at that point. So when we drill that down to what that means for the customer over the full year, the number of services for the cantilever pump was 9, whereas we're talking about 4 for the Flygt product. And I mean, again, that's been quite harsh on the Flygt product there. But the number of pumps that the cantilever had on site was 13, and now we've got 13 Flygt pumps. So that means that we had a total annual OPEX spend of our operational costs of 1.7 million for the cantilever pump, whereas we managed to reduce that to 800,000 for the Flygt slurry pump, which in reality is probably much less than that. But that's an annual saving of 950 or nearly $1 million each year. And again, this is why I love working with Xylem, because we didn't just give them a product and move on. We helped work with the customer. We noticed that there was some operating philosophy changes that needed to happen. They really needed to implement level control, but also we helped them with the best product for their application of what we seen fit. So, and we're still working really closely with this customer today, and continuing to help them optimize their processes. The next case story is a coal loading terminal. We managed to change these pumps out a long time ago, and what we wanted to do was work out how much it was costing a coal customer over the period of 6 years. One thing about coal is if you've ever met anyone that works with coal, you'd understand it gets everywhere. and when you come home at night, they're generally, or if you're ever walking about site, you'll see they're generally covered in coal. Or if you're in a process facility, you'll see that there's coal absolutely everywhere. So the solution they had originally was a cantilever pump, no surprises there. But they had 50 sumps in this operation, and this is a coal loading terminal. So a coal loading terminal is the coal's getting mined in Australia, it then gets trained to the port and then dumped onto conveyors where it's moved around site, stockpiled, and then eventually loaded onto ships and sent overseas. Now, the interesting thing about coal is because it's so light, it blows off the conveyors. A lot of times when you're on ore processing facilities with heavier materials, you'll find floor sumps are only at junctions or where you're moving from one transportation method to another, i.e. you're moving from the train to the conveyor, or you're moving from the conveyor to a stockpile, or you're moving from the conveyor to the loader to the ship. With coal, you're finding these floor sumps everywhere because anywhere there's a conveyor, you just get coal blowing off the conveyor, and you just tend to find them everywhere. And we managed to change 50 sumps and standardise them again to the 13.5 kilowatt. Again, you notice that it's a smaller pump size, again, because the density of coal is much lower than zinc. We worked it out that it was costing the customer an average 3,215 Australian dollars to maintain each sump per year. And the customer was operating with 10% rotable spares, which meant for the 50 sumps, they had to have 55 pumps. And out of them 55 pumps, 3 of them would be in stock, ready to rotate out with the other sumps, and 2 would be at a Xylem branch for repair. So again, they've standardised on the one model across the site, and the pumps are being maintained at a Xylem branch. And the great thing about this is the Xylem branches are servicing more than one customer. So they've got the ability to hold a lot of stock of all the spare parts. This removes the need for the customer to take that on with a lot of spare parts, and they can just hold the rotational spares on site, and they can just keep moving them through the fleet. That's the benefit this customer sees and still sees to this day. Some of the applications across site, mostly floor sumps, which are off the side of access roads. Obviously, we need to keep the access roads clear, otherwise you can't drive through them. Train loadout, so when the trains come in to be unloaded, they're spun round and dumped onto the conveyor belts. You get a lot of run out, and that's where our pumps are found down the bottom of what you call, I don't know if this is what you call them everywhere, but we call them car dumpers here. Conveyors, again, as I mentioned, because of the low density of coal, all along the conveyor circuit, you're going to find floor sumps all along the conveyor circuit, and it's ship loading as well. Some of the site-specific requirements was agitation, which again comes as standard, but because we're retrofitting into different floor sumps again, we went with a side-mounted mixer again, and some zinc anode kits just because we are so close to the port. Again, one of the key benefits to this is our Xylem branch, which helps service these pumps in a timely manner. But these pumps are very straightforward to repair as well, so they can be repaired on site, and there's very little spare parts to these products. But this customer found that sending the pumps back to Xylem to be repaired and just having them in rotation was a lot more straightforward. So looking at the annual OPEX spend against the initial CapEx, it's at 14% of the initial CapEx spend, which for slurry pumping, when you're talking about such a highly abrasive liquid that wears down a lot of parts, that's a pretty good result. And 14% of the initial CapEx spend, the customer's really happy with. That concludes my part of the presentation, so I just want to thank everyone that's in attendance again, and thanks to the mining COE for asking me to do this. And I'm just going to pass back to Liran, who's going to have a couple more slides on some product, and then we will be available for questions at the end. Thanks very much.
Thank you, everyone. Thank you, Ryan, for a great comprehensive product presentation and case studies. Really understanding the application and selecting the right pump is key for delivering the best solution for our customers. However, for a complete pumping solution, we need to think about operating philosophy, and some form of monitoring and control measures should be bundled with the pump. The Flygt Pareo is a relatively new pump controller unit from Xylem. When the Flygt Pareo is connected to a submersible dewatering pump or slurry pump, it basically delivers a smarter drainage pump solution for the mining market. It allowed also the customer to adapt to the growing needs and demands of automation and connectivity in the industry, as well as reduce the maintenance and the downtime for the pump. So just a little bit on the Pareo features. The Pareo features built-in sensor, built-in a snore, dry run control, also automatic phase rotation control, overcurrent, high temperature, and it can also detect phase imbalance losses and provide under or over voltage protection. This unit has also a Bluetooth and a Wi-Fi and also modem capabilities, and it can be controlled via a smartphone app. The Pareo can also connect to a SCADA system. You know, it's very common nowadays that there is already a digital platform, some form of digital platform already implemented on site. Often it's SCADA. So this Pareo unit can connect to the existing SCADA system. If you want to know more information about this product, please contact your local Xylem rep. And with that, we reached to our Q&A session. I think we have between 10 and 15 minutes or something like that, as long as needed, to answer your questions. So I will ask the rest of Mining Center of Excellence member to join us on the panel for the Q&A, please.
This one's from Somi, and he asks, is there an allowable minimum sump height? Any suggestions?
Well, I think there are a couple of things we need to remember. When you say sump height, do you mean minimum water level or the sump itself? Shane?
I think it's been in the sump itself.
Often the sumps where our pumps are fitted in are replacing a deeper sump, because when you use the cantilever pump, these are often relatively deep sumps. So our pump normally have enough space there to be installed, and also the water level probably should be covered the motor.
Yeah, it just really depends on the amount of flow that's coming into the sump as well, and how much medium. So it's all dependent on the flow coming in. We want to try and keep the sump as small as possible so we can agitate as much of the solids as possible, but at the same time we need some retention. We don't want to pump all the water out straight away.
Probably in addition to that, Ryan, nowadays it's good practice to make the sumps with a tapered bottom to feed all the solids into the center. So you can use your agitator and on the bottom of the submersible to extract all the solids from the sump, and that'll ensure that your sump keeps clean. But yeah, just to confirm what Ryan mentioned, that really depends on inflow is the key, because the last thing you want is your pump starting and stopping too regularly. So there's multiple things to look at. Height is not just one of them.
Okay. Question here from Danny. Agitator versus mixer. Which is better, do you think?
I think if we can get away with using the agitator without the mixer, it's always better. You've got less components that can go wrong. And as well, if you've designed the sump to suit the Flygt submersible pump, you should have the sides tapering down, as Paul mentioned, towards the agitator, which really helps you kill any dead spots. Mixers should only really be used when we've got large sumps, which have dead spots that are there prior to the initial design.
Okay.
Just
question
to add
from-
on that, you know, agitator really provide just local agitating under the pump, where mixer is probably going to suspend the solids in a radius of 1 meter around the pump. Ryan mentioned, you know, obviously, you know, the thickness of the slurry, concentration of the slurry, all this will have impact whether we select the agitator or mixer, but it's always better to start with agitator.
All right, Jefferson asks, do we need to add head if the client gives us the TDH of the slurry, but the selection curve is based on clean water?
I'll maybe take that one, Liran. I think with it all depends on how much solids are in the liquid. Now, one thing with what we're talking about here, when we're talking about floor sumps, is the reduction in head with the amount of the concentration of solids we're talking about isn't massive. But yes, you need to take it into effect.
Okay. Najaka, if the customer requests for super duplex material for the casing and impeller and wear plates, are they available?
At the moment, no.
Okay, it's quick and easy. Are there any plans to modify the 5000 series to have flanges cast with the casing rather than a Victola coupling?
Oh, is that something you could maybe take? That's something we get from customers reasonably often.
Look, there's no plans immediately, but we've always got a funnel for product improvements, and we'll certainly continue to push that out for a change.
From Tish Pang, the agitator. What is the impact of the agitator on the efficiency and motor size?
No, the agitator basically add a little bit of additional power load on the motor, not significant, but that's something that obviously the curve will be adjusted slightly because of you fitting agitator.
But it doesn't have any effect on the pump performance curve.
Not on the curve itself, more on the power consumption a little bit.
Yeah.
From Durga, do we have a top discharge design in the 5000 series slurry pumps?
We don't have a top discharge design as such, but we've got a discharge connection that's available upon order that will give you that top discharge. So basically, it's mounted to the discharge and feeds up the side of the pump to give you a top discharge.
Okay, question here from Larry. The opportunity to replace Warman slurry pumps with 5000 range in dry installation.
Is that with reference to process pumping?
I think it would be,
yeah,
I think it, sorry.
Yeah, no, carry on, Shane.
I was thinking, I think the question's around the old Warman style cantilever pumps, perhaps. But he's talking about dry installation, so maybe process pumps.
And suctions.
Yeah, process pumps. We don't really play in that space. It's more around floor sumps and washdown sumps. But where there's Warman cantilever pumps and floor sumps, then definitely that's something we can replace.
Rick asks the question, if I need some technical support on Pareo, who is the best person to contact for that?
The best person to contact would be your local account manager, who will put you in contact with an M&C specialist for that product. So your first point of call is your account manager. Speak to them. If you don't have one, reach out to the branch, and then they'll put you in contact with a technology specialist.
one from Somi. Which models do not have an agitator underneath?
No, so there's only one or two models that don't have the agitator available, and that's the very small units that like 3 and 4 kilowatt, and that's purely because of the available power that Liran was speaking about before when utilising an agitator. But pretty much 98% of the product is available with agitator.
So everyone attending, I want to thank you really for listening, and hopefully you learned something from this presentation. Want to thank you again for your time, and we'll see you again in our next webinar. So stay tuned. Thank you very much for attending again, and have a good morning, good day, good night, wherever you are. Thank you.
Thanks very much.